right, so what I want you guys to do, and this is just to eliminate any temptation. I'd like you to close your computers, maybe put them on the desk or to the side or whatever. I'm a person that believes that if the temptation is there, somebody's probably going to maybe open up Google and start playing games like that. So if we don't need them out, I'm gonna ask you to keep them away. And if we need them later, we can get them out. But just eliminate that temptation to keep people from maybe getting themselves in trouble in regards to falling behind if they want to do something else. I would like you to get a piece of paper out, some notes out, something you're going to keep. We're going to try to set the foundation of geometry. Before we get into any of the geometry, a couple things I think are kind of important to talk about and discuss the way I view just the way we should kind of interact in the classroom. First thing is, anybody like baseball in here? Anybody like, watching sports on TV, whatever, or if you like this, I'm a huge baseball fan, okay? Huge Cleveland Indians fan, and if I'll go home tonight and watch the game last night. I'll probably watch anywhere between 100 and 160 games in a season of Cleveland Indians baseball. I'm not watching, I'm listening to it, okay? So I'm just always tuned into it. And if you gave me a baseball bat and put me in front of Corey Kluber, who's one of the best major league pitchers at the moment, and asked me to hit his 95-mile-an-hour fastball, I'm not going to be able to do it. Okay? And I'm not going to be able to do it even though I watch him every single time he pitches. Okay? Even though I watch other guys pitch 95, 96, 97 miles an hour, I'm not going to be able to hit that baseball. Okay? Who likes music? Okay? Who do we listen to? Give me an artist. Adele. Okay? All right, man. All right, so I'm listening to Adele every day. Now, I listen to Adele on the way to school, on the way home to school, Friday nights, get pumped up for the football game, listen to Adele. Okay? If I'm doing those things, and can I take my headphones off and can I sing like Adele? Probably not, right? Okay? Because I'm not going through the lessons that Adele's going through. I'm not going through the training of my voice like she does. Okay? I'm not going through the batting practices and the little technique things that all those major league batters are doing to hit those 95-mile-an-hour fastballs. Okay? So my thoughts are here, and what I'm trying to relay to you is you cannot be successful in this class by sitting and watching. Okay? You cannot be successful in this class by sitting and listening. Does that make sense to everybody? You can't just use those individual senses and be successful. Okay? You might see some success, but you're not going to maximize your potential. Okay? So what you have to be able to do is you have to do something. Okay? You have to go through the motions. You have to participate and be active. And the way I'm going to ask you to do that is to take notes. Okay? Ask questions. Okay? And when you start doing those things, when you're taking notes, you're watching, you're listening, you're doing. You got that kinesthetics aspect of it. Okay? And information is going to retain and be retained a lot more if you're doing all those things. Does that kind of make sense to everybody? Okay? So you cannot just come to class and say, just because I'm here, it's going to be like osmosis and it's going to sink in and I'm going to know everything. Okay? It doesn't work that way. Okay? So, that being said, please be active in regards to taking notes. So let's talk a little bit about what we know to be geometry. Okay? Geometry to you guys right now is you're probably thinking shapes, you're probably thinking circles and squares and rectangles and triangles and that kind of stuff. And my hopes are that we recognize that, yeah, that's part of it, but there's a whole lot of geometry that is out there that we don't maybe necessarily think about as being geometry. Maybe you can recognize it as being math. we're trying to teach you how to think, okay? Or to think about the way you think, all right? And that's a little bit kind of weird to think about, but as we progress through this class, we're going to try to approach geometry in a manner in which a guy named Euclid did, okay? And if you see this is on Wikipedia. I just wanted to get some dates here for you. 300 BC is about the time that Euclid was living, okay? So quite a long time ago, right? Okay. And what Euclid was doing when he was alive was he was very interested in mathematics. And these guys back in these times, like Plato and Aristotle and Socrates and Euclid, and those types of people, they were like the rock stars of their time. They were the LeBron James, they were the Beyonces and Jay-Z. Okay, it was high society to be a thinker, to be a philosopher back then. Okay. So he's one of these guys, and a lot of times they these people like followers, okay? They had their cronies, like, you know, Beyonce has her followers, right? Jay-Z has his followers, his entourage, okay? These people have like schools of thought, and Euclid was one of these people that was kind of the head of that. And what he did is he started to take a bunch of information that was prior to him, and stuff that he was working on, people that during his time were working on, and he just kind of combined it and basically said that all the geometry that we currently know and that all the geometry that we're going to learn in this class, and even beyond that, is all true because of 5 or 6 basic rules. Okay? Now, yesterday I told you that in this class, we're always going to be able to ask the question, not what do we know, but how do we know? Can we answer the question, why is that true? Why is that statement or that fact true? Okay? And we should be able to do that almost all the time. Okay? But there's a couple, 5 and 6 statements that he came up with that we can't do that with. We just have to assume them to be true. It's kind of like building a house. We're going to build on top of the foundation. We'll build our walls, and we'll build our trusses, and we'll put the roof on, all that kind of stuff, right? But we've got to have somewhere to start. We've got to have a ground to start with, a level ground, right? It's the same thing in geometry. We've got to have some level ground to start with, and that level ground is 5 or 6 statements. Now, his 5 or 6 statements, and to be honest with you, I've never looked at it in his book for the elements. I don't know how long they are, but I'm assuming that his 5 or 6 statements were not really concise. They're probably pretty long. Our textbook takes his 5 or 6 statements and breaks it up into about 30. Okay? It makes it easier for us to deal with and easier for us to use them. Okay? But they're statements that we cannot prove. We just have to assume that they're true. Okay? We'll talk about what those are down the road. But he said that everything that we have come across geometrically can be traced back to basically those 5 things. We can take 2 of those things, put them together, and then create a 6th thing. Maybe now we take 2 or 3 of those 6 things, put them together, organize them in some way, and then create a 7th thing. And we keep doing that, and then create the entire system of mathematics, the entire system of geometry. Does that make sense, everyone? Okay? So, he did this, 2,400 years ago. Okay? His book, The Elements, is still one of the most published books and most used books in college mathematics world. Okay? This dude was right. Okay? So when we talk about Euclid in the geometry, we just say geometry. We're talking about Euclidean geometry. There are other geometries. So what happened is that he developed these rules, and throughout the span from when he did it to even now, people have been attacking them and saying, no, we don't need this rule, we don't need this statement. And they take it out, they delete it, and they say, okay, if I delete that statement, how does geometry look now? Does a right angle still look like a right angle? It's still 90 degrees, okay? Or because I removed that, is now a right angle maybe 85 degrees instead, okay? So they've been doing that, and basically what people have found, mathematicians have found, is that his 5 or 6 rules were pretty rock solid. They can't debunk them, okay? And then people even say, well, we need one more. We need something extra to really make the geometry work. And then they put that extra statement in, and they go through combining them and making new things, and they find out that, hey, we still get all Euclid's geometry with or without that extra statement we put in. Okay? So, over 2,300, 2,400 years, we've got a pretty good, solid foundation that we can use to develop the rest of our geometry. Okay? Does that kind of make sense to everybody? Just want to give you a little bit of history about what we're learning, all that kind of stuff. We break down geometry. A lot of the math that we deal with, it comes from the Greeks. Okay? A lot of it comes from Italy and India and those areas. But this guy, as we read through there, from Alexandria, the Greek. It's called founder of geometry, father of geometry, that kind of stuff. When we talk about geometry, that word means geo. What's geo referred to? The earth, right? Okay. And then metry, what's metry sound like? Measurement, right? Okay. So when we talk about geometry, we talk about earthly measurement. Okay. Measuring things on this earth, measuring things within our existence, kind of like the places that we can go. Okay. And we even use obviously geometry to go places like Mars and do things about deep realms of space. But there's arguments that maybe Euclidean geometry. The geometry we talk about on Earth might not be the best way to describe measurements at the ends of our universe, stuff like that, the ends of space. So it's very, very complex, very, very hard to think about before we get into geometry. But we're going to spend most of our time on Euclidean geometry. All right. So that being said. Definitions, guys. Okay, so a definition is kind of the best way that I found to be able to explain this. Okay, since in geometry definitions are found using known words or terms to describe new words, right? Does that kind of make sense? And that's how you know any definition or any vocabulary word in any other aspect of life, whether it be science, English, whatever. You're using already understood, already known terms to define something new. Okay? And basically what we're doing with definitions, we're creating a statement that's going to allow us to categorize and identify something. Okay? And be able to talk about it. Okay? Well, right now, the way I want you guys to view what you know about geometry is that you know absolutely nothing. Okay? You have absolutely no idea anything about geometry. Coming in here, just a fresh slate. Okay? So, if I'm going to start building ideas, but I don't know anything, how am I going to do that? What am I going to use to build those ideas? I can't use previous terms because I don't have any previous terms. Does that make sense? I don't have any previous definitions to create new definitions. So what we do, or what we have, are what we call undefined terms. Okay? They really, they have things, some characteristics that we're going to talk about. They don't necessarily have a formal definition. They've never been formally defined. We're just going to start off and say these are what these things are. Does that make sense? This is what these things are. And three of these undefined terms are points, lines, and planes. And once I have those three things identified, even once I have a point identified, I pretty much have the ability to essentially talk about every other vocabulary word and definition that we're going to see in this course. Okay? So a point, and you guys dealt with points in algebra, when you plot lines, ordered pairs, and that kind of stuff. Those are points. Okay? In geometry, all we're going to do is we're going to say that it is a location in space. I'll give you the definition. I don't want you to write that down right now. That's a little bit too much to write down. I want you to write that definition at the top. Okay? You don't need to write everything after that. Just write a point is a location in space. It has no size. And we're going to represent it with a capital A, capital B, capital C, whatever letter we want to use. So we're going to use a capital letter to identify them, label them, name them, however you want to refer to them. But a point, as you're writing, a point has no size. Okay? It's just a location. It's just a spot in space. It's got no thickness, it's got no width, it's got no depth. Okay? We're just highlighting some location with that circle that we draw. Does that kind of make sense? Okay? question is, if we're going to label these points with capital letters, how many points can we have? I think the most common answer is when we label with capital letters. 26, right? We got 26 letters in the alphabet, so people think I can only use 26 letters. But what if I go through, I'm going to show you something real quick. Okay, can you guys, let's see here. You know, we plot that point. I can plot that point. I can go there. I can go there. Okay. Can you visualize that I can probably do that more than 26 times? Yeah. There's an infinite number of points that we can kind of deal with. Okay. And to give you kind of a calculus idea, if I were to zoom in just on this block between 1 and 1 right here, okay, that little square, does anybody know how many points are going to be inside that little region? There's going to be an infinite number of points in that little region. Okay? Even if I zoom in on this little block right here, okay, there's going to be an infinite number of points inside there. Okay, and they're all just jammed in really close to one another. And when I want to identify one of them, I want to locate one of them, I just highlight it with a point like we have there today. Okay, so we have a lot more points than just 26. If I ever want to talk about one of these points, let's just look at 1, 1, and that point at 2, 1, so this one's A and B. Maybe for some reason I wanted to use the same letter A. Okay? I can do that. Alright, but if I do that, let's see if I've got my tablet somewhere here. See on the little gray tablet. There it is. There it is. Okay, so let's say that B wasn't there, and I want to call it A again. Okay? And if I ask everybody to look at point A, are some of you going to be looking at this point right here? Are some of you going to be looking at this point right here? Okay. Okay. Let's say that I had 2 students in here named Ian. And I said, everybody look at Ian. We're in the same situation, right? So how do I differentiate between everybody looking at the correct Ian? What do? I say their last name. Okay? Or maybe a nickname, that would work, okay? So I say their last name. So I say, everybody look at Ian Strang. And now we know everybody's eyes are on him, right? We'll forget about the other Ian. He's on the special. Okay? So, how do I do that with these letters A? I give them a last name, right? Okay, so if there's one way of doing this, I can say, I'm going to let this red one be A, and we'll let this one be A. We put a little apostrophe, a little tick mark up there, okay? And we read that as A prime, okay? So now I say, everybody look at A, we're looking at the red one. I say, everybody look at A prime, we're looking at that one on the right. Does that make sense? Okay. If I wanted to use A again, maybe there's another point down here, and I want to use that same type of notation, I just put 2 of those things there. And now I say, everybody look at A double prime. And I can keep doing that. We'll use A again. Everybody look at A triple prime. Okay? And then eventually, obviously, I don't want to put 4 of those up there, 5 of those. Now it gets kind of messy, right? So what we do, if we want to use A over and over and over again, if I use it 8 times, I'll use this one 8 up there. Okay? Is that okay? That's one way of doing it. Another way of doing it is actually to use, instead of, those primes are superscripts because they're up top right, and we can use what we call subscripts. So let me rename this one as A sub 1, rename this one as A sub 2, okay? And now we can look at those and say, I really get A, I really get A sub 1, I really get A sub 2, and we're all focused on the correct point. Is that right? Okay. The reason I thought, some of you might say, well, that's obvious, I know that. We did X1, Y1, and X2, or sorry, yeah, X2, Y2 last year in Algebra 1 with slope and that kind of stuff. But we talked about that because I think one of the hardest things in any math course is being able to read what they're telling you. Okay? If I can read it, that's the first step. Okay? If I can't read it, I don't know what the notations, I don't know what the symbols, the letters mean, there's absolutely no way that I'll be able to go through the logic and the calculations and that kind of stuff. Does that make sense? If I walk into English class and I don't know what a comma is, I don't know what period, semicolon, ellipses, apostrophes, that kind of stuff, question marks, exclamation points, I'm not going to be a very good writer, correct? So if we don't know the notation and the symbols that are used in math, I'm not going to be a very good mathematician. Okay, so I think that's very important to kind of discuss and talk about. So those are points. Okay, the next vocabulary word I want to talk about is space. Okay, space is just the collection of or set of all points. Okay. The mathematical definition for a set of things is just a collection of things, a grouping of things. So right now, space is just a grouping of all the points that we can ever imagine existing. Okay? You guys are familiar with the two-dimensional plane, the XY axes or the Cartesian plane that you graphed lines in last year, right? That is just a portion of space because those points, you can only move them left and right and up and down, or variations of those things, or combinations of those things. When I add space in, we can now move those points closer to me and further away from me. Okay, so I add depth. So I'll come back to this slide in a moment for you, but right now this is kind of what I was talking about. This is what you guys are most familiar with. This is two-dimensional. I can only take point A and move it left, right, up, and down. Does that make sense? Okay. I want to do that with A prime or A1 and A2. But when I add this idea, okay, now I can take those points in the plane that we were seeing previously, where A1, A2, and D were in. That's now the gray plane. Okay? And I can still move those points in those, left, right, and up and down. So this would be moving that point, left, moving it right, moving it up, moving it down. But now I can move it off that plane, right? So now it's kind of floating there, right? Does that kind of make sense to everybody? All right, so that is what that point A sub 2 is part of space. A sub 1 is still part of space. But as I start thinking of all the infinite number of places that A sub 2 could go, all the collection of all those places could go is what we call space. Is that doable? Okay. That takes us then to this idea. Okay. Just simply, and this is where we'll stop today. It says all other geometric figures are made up from an infinite set of points. Okay, you don't need to write that second bullet down. I'm going to try to explain that with a visual here in a moment. But all other geometric figures are made from an infinite set of points. When we talk about triangles, most people think about 3 points. When we think about squares, we think about 4 points. Okay? And those are 3 or 4 critical points. They're very useful points, but those are just the vertices usually that we're thinking about. Okay? And they help us define our shape, but there's a lot of other points in there that we need as well that we should talk about. All geometric figures are made from an infinite set of points. The way I like to think about this is I take one point and I highlight it. Okay, and I move it a little bit and I highlight its location. And I keep moving it just a little bit to keep highlighting its location. And if I do that enough, eventually something good should really happen for me in regards to other shapes. So I'm going to, just for the sake of time real quick, move back to this to show you that. So would you guys agree right now that C, and I don't even care about the axes or anything like that, would you guys agree that C is some location in space? Some point, okay? I'm going to identify that location. I'm just going to highlight it. And then I'm going to make C go somewhere else. And I keep doing that, okay? Now there's some gaps between the locations that I chose, right? Would you guys agree that in those gaps, there are some other points? And I can highlight those points, right? And then in between the other gaps, there's more points, there's more points. And to be perfectly honest with you, okay? When I zoom in enough, okay, so if I zoom in between these 2 points, does anybody want to take a guess on how many points are between those two? There's an infinite number of points in between those two. But if I'm able to fill them all in, okay? I was able to fill in all those infinite gaps. What shape do we create? A portion of a line, right? Okay, we call that a segment because it's going to stop. But that is a collection of an infinite number of other points that we highlighted. Okay, and we moved on and highlighted another one, we moved on and highlighted another one. Does that kind of make sense? Okay. So then when maybe we get that point C to maybe change directions, make another segment, and then change directions again, make another segment, and eventually maybe we trace out a triangle. Or maybe we trace out a rectangle or something like that in the future. Alright? So the collection of all points is space, and all other figures then are created from an infinite number of those other points. Okay. We'll stop there. No over this section tonight.
Pardon the interruption for a couple afternoon announcements.